Okay, so we are going to take a look back at exponents and radicals. So we've actually covered both of these topics, but today we're going to use this time to review them once again. So we're going to apply those exponent properties and then use what we learned about simplifying radicals. So first we'll start off with exponents. So I will still go over it, but keep in mind we have done this so far. So our first one, we have 2x to the fifth raised to the fourth power. So because these are in parentheses, I know that that 4 has to go to both pieces. So in other words, this would become 2 to the fourth, and then it would become x to the fifth to the fourth. So 2 to the fourth is really 2 times 2 times 2 times 2, which would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So we would have 16, and then we have x to the fifth to the fourth. So I know I multiply those. So it'd be 16x to the 20th power. All right, looking at our next one. So these ones, we don't have any parentheses, so I'm going to just go ahead and multiply them. So remember we talked about in class, but a lot of people want to add those numbers, even though they're numbers, but we get kind of confused with the properties. So we have 3 times 6, so that would be 18. Now we know that technically there's an invisible 1 as an exponent there. So we have x squared times x to the first, and I know that when I multiply exponents, I really add them. So this would become x to the third. So our final answer would be 18x to the third. Now this next one, we have some parentheses, so we'll deal with that first. So we have x squared to the negative 2, so this would become x to the negative 4. And then we just have times 3x cubed. So first I'll deal with my numbers. So technically there's a 1 in front. So I have 1 times 3, which is 3. And then now I'm multiplying the exponents. So I know when I multiply them, I really add them. So I'd have negative 4 plus 3, which would be negative 1. Now, we also learned a property that you can't have negative exponents. So what we do is we're going to move it to the bottom, and then the 3 stays on top because there is no negative exponent connected to that 3. Now, I really don't need that 1, so I just went ahead and erased it, but if it's there, it's not wrong. Okay. This next one, we have parentheses, so I'm going to take this exponent of 2 and distribute it to both parts. So we would have x to the negative 2 times 2, which is negative 4, and y to the negative 4 times 2, which is negative 8. And then our next step here, we can't have those negative exponents, right? So we're going to move both of them to the bottom. So it'd become x to the positive 4 and y to the positive 8. And then the coefficient or the number in front of the variable will go on the top. So in this case, it would just be 1. Remember, there's invisible 1s there technically. Okay, looking at this next one, we have x squared to the negative 1. So this would be x to the negative 2. And then times, and I'm just going to go ahead and write this out, 4x to the negative 5. So I'm going to go ahead and put an invisible 1 there, and I'll multiply the numbers. So 4 times 1 is 4. And then I know that I'm going to add those. So I have a negative 2 and a negative 5, which would be negative 7. But we can't have negative exponents. So I know that on the bottom, it's going to be x to the positive 7. And that 4 is allowed to stay on top because it doesn't have any negative exponents connected to it. All right, you can see that this one's kind of getting a little harder here. So let's first deal with the numbers. So remember, we're not going to subtract them. We're actually going to divide them. And the reason why I said subtract is because there's an exponent property that when you have the same base and you're dividing, you really subtract. But these are numbers. So I know that 18 divided by 9 is just 2. okay? Now I'm going to deal with this part. So I have x to the 7th and x squared. So because I'm dividing those, I will subtract and I'll get x to the 5th. Now this part, I know that this is technically a 1. So I have y to the 1 over y to the 5th. So I subtract those and I would get 1 minus 5, which is negative 4. Now this is almost looking good, except I can't have that negative exponent. So I'm going to move it to the bottom and make it positive, and the rest of it stays on top because it doesn't have any negative exponent. All right, so this last one is a challenge, but we're definitely going to try it. So I'm going to deal with the numbers first. So I know that if I have 12 over 24, I can reduce that to 1 over 2. Hopefully we all agree with that. Now I'm going to kind of deal with my x's. So on the top, you'll notice that we have x cubed and x squared. So I'm going to go ahead and make that x to the 5th. Because when we multiply exponents, we really add them, and then I have a y, and then I'll kind of just rewrite everything so far. All right, let's go to the next stage. So I really don't need the 1 there, right? Because 1, I can just kind of leave it, but we can keep it there if we want. It's not wrong. But I'm going to go ahead and deal with the x's. So I know that when I divide exponents, I really subtract them. So I have 5 minus negative 2, which is 5 plus 2. So this would turn into x to the 7th. Right? I can keep the 1, I cannot. I know the 2 is on the bottom. Now I have my y's. So this is really a 1. So I have 1 minus 4, which would be negative 3. But I can't have that negative exponent. So I want to rewrite this. So x to the 7th will stay on top. And then 2 is on the bottom, and then I'm going to move y to the negative 3 on the bottom and make it positive, and then that would be our final answer. So that's kind of a review on exponents. So if this is still confusing, I would recommend going back and watching the original exponent video. All right, so now we're going to look at radicals. We won't do as many radicals because we spent a longer time on this. And I noticed that most students find the radicals section a little bit easier. So the first thing we want to do with this 108 is start branching, right? So we talked about different ways to do this, so it's whatever way works best for you. I'm going to do 2 times 54, and then 2 times 27. 2 doesn't go into 27, so I'll do 3 times 9, and then 3 times 3. We're looking for pairs, so we have that pair of 2s, the pair of 3s, and then we have a lonely 3 by itself. So for the pair of 2s and the pair of 3s, that would turn into 2 times 3, and then root 3. So another way we can write that is 6 root 3. So remember, the lonely number goes inside. Think of it like the lonely number goes inside, stays inside because they have no friends, right? So next one, square root of x to the 5th and y to the 22nd. So this is strictly just variables. So remember, we're looking for pairs of x squareds. So how many x squareds are in x to the 5th? There's 2, right? But then there's 1 left over. And for y to the 22nd, how many y squareds are in y to the 22nd? There's 11. So remember, we talked about you're essentially just dividing it by 2. And then if it's an odd number, you'd have a leftover one, right? So 5 divided by 2, it's 2, but then there's a leftover, okay? Okay, here's our last one. So this one has 2 different pieces within it. So we have both a number and a variable. So I'm going to go ahead and deal with 50 over here. So I'll do 2 times 25 and 5 times 5. So we have our lonely number of 2, and then we have our pair of 5s. So I know for the number piece, I would have 5. I'm going to leave some space and then root 2. Now for the variables, x to the 7th, we're thinking how many x squareds are in there? There's 3, and then there's 1 left over. And then for y to the 6th, how many y squareds are in there? There's 3, and then 0 left over. So this would be our answer. So same as I said before, if this was not enough, so if you feel like you need more practice on radicals, then you can go ahead and go back to the original radical video.